Okay. We have a lot of things to cover, so we're going to have to move along a little more quickly than we have actually. Okay. So we gotta get going on a few things, or we're gonna miss out on getting all the material done. I went through this last year, so I'm not really going to spend too much time because what you can do is go ahead and read through it yourself when it comes to the programming life cycle. Okay, but just to quickly reiterate, when you start off the life cycle, you have to analyze requirements. So that's usually involves meetings with clients, your customer, between the technical staff and the client. Usually it's somebody that's very good at being able to gather information from a client. So usually somebody more along the senior lines. But it's always valuable for you if you're going to be working in a co-op position, whatever. What are you guys doing? Hey, so you guys should be on the screen. You should be all looking this way. I don't know what you guys are doing over there. Come on. So if you're going to end up having a work, and you shouldn't be messing with anybody else's computer up, you know? If you're fooling around. I already told you guys a million times, don't mess around with stuff. Did you switch them or something? Oh, dude. Come on, there's no time for fooling around. So it's important. It's good experience if you have a job where you can be in some of these meetings, where you can be with the like a senior programmer analyst that's dealing with the clients or dealing with. And a lot of times we refer to the clients as even someone within your own company. So you're the IT part of the IT department, and then you're dealing with the business side to make some apps for them, or whatever it might be. So you got to gather all the requirements for your particular project. Get everything that you can. Whatever they want, dream big. That's what I always say. Then you have to scale back within the amount of time that you have to deliver whatever it is to be delivered. So it usually involves a number of meetings back and forth. Get what they want, everything. Then you have to say, well, you want this done in 6 months or 3 months, whatever. This is what you can get. You know, with this amount of resources and these kinds of, and that comes with experience being able to figure that kind of thing out. Once you have all the requirements and you decided on what the program is going to be, what the software solution is going to be, so then you move on to the next phase and you start to design. There might be a number of technical scenarios that you might have to figure out, right? One of them might be this system has to talk to that system, and there's something that exists that's out there. We have to figure that out, right? Before you even commit to this, you might even be, while you're kind of reviewing the analysis, you might actually have to say, hey, get a few people on the team. Check out if we can talk from this system, that system. Is it doable? Will it work? And what's it like? Right? Because a lot of times you're going to have to do things that you don't know. Sometimes you maybe never did something, but you know it's doable, so you just have to add that into the time frame of how long you think it's going to take. Once you finish design, so then you're going to have to design everything. Where I'm going to show you this year, we're going to design our classes using Unified Modeling Language, or UML. And we'll just kind of use things on there to kind of model what classes are going to look like before we actually build them. You want to start thinking about it. You want to make sure that things can tie into each other and before you actually go ahead and code it. Because you can start coding things and totally be way off and have to scrap everything. I've seen people fall into that trap. So as your software gets very complicated and bigger, you gotta really have a pretty good grasp on how you're going to do things. Okay, so that comes inside this design phase. So we'll look at that this year by looking at UML. Okay, and then you go ahead and code the program. We don't do that, and then you got to test it, right? And as you're coding, you're always testing what you're working on. And this test is a test of the whole system, right? And then any bugs go back to here, and here, and then here, then you test again, back here, here, here. Once it's all done, it goes in, and it's released to the public or to the users, and then they use them. And sometimes they still find bugs, so a bug might get found after months of using it, something went wrong, and you're like, oh, we never noticed that, okay, that's great. And then it goes back here through the cycle, and then gets released. We used to have bug updates usually once every 2 weeks or once every week. I think at first it used to be once a week, and after that, usually weren't critical. Usually a couple weeks. You put a whole button release, right? And every 2 weeks the release would come out, and that would be internally how we used to do things at some of the places I worked at. Other than that, you might have version 1, and then you've already planned for version 2 to come out 6 months later, which includes bug fixes and maybe a whole bunch of features that you didn't have the time to complete, and then you add them into a phase 2 or a version 2. Then you have phase 3, version 3, whatever, and it just keeps evolving until you discontinue that product or evolves into something completely different. Okay, so we kind of talked about that last year, so we're not going to go into too much of that. But like I said, we're going to focus on this class diagrams, so we'll see those. So I would recommend reading through this, making sure, in case you're kind of confused on any of these points. It's pretty straightforward, but one of the things that we should add into our programs, particularly if we're going to build some games, is enumeration types. So you can put. It's not working too good. So an enumeration type is kind of like it's like so off. It's not even funny. Ay, ay, ay. Let's hope the pen works. So an enumeration type is, let's say you created a little object that moves on the screen, and it can move in 4 directions: north, south, east, and west. And so when I design my software, I don't want anybody to use anything else other than the north, south, east, and west. I want it to be strict. I want them to adhere to those rules. So if I create a method and I ask as an input, let's say, what's the direction that this particular object is moving in, I don't want them to put an invalid input in there, which would be anything other than the north, south, east, and west, the 4 directions, right? I mean, we could create a numbering system such as maybe we could create constants in our program, and then we set north equals to 0 and south equals to 1, and we could do that kind of thing. But the problem is that when I go ahead and or somebody uses, right? So I have more than one person using working on my team, or even if I'm doing it at a later date and I use that particular method that wants me to add a direction, what if I put a different value in there other than the ones I designated? Maybe I forgot. I thought 5 was 1 and it's not. Right? It becomes a problem. So in order to kind of put this strictness in there, what we can do is instead of using constants of these guys, we can use what are called enums. And you guys have already been using them in a way. So if you put the word public in front, now you can put this at the beginning of a class. So we'll look at it a little bit later, but I'll introduce it now. So you do public enum, and then I believe you put the name of it. So let's say directions. And then you put a little thing like this. As long as I have this in the word public in it, I can put it in any of my classes in my project, and then I'm pretty sure it'll recognize it everywhere. When we look at it later on, we'll just test it out and make sure. I don't want to really jump there right now, do an example with it, but I'm pretty sure that's how it works. And then all you have to do is list what the directions are. So I would say north. I think you have to put a comma. I usually just list them like this. You put a comma. Is that what it says on the notes? East, north, south, east, and west. Is there a semicolon at the end here?
Yes.
So these have commas, and this one has a semicolon at the end, right?
No, it's after the curly brackets.
After the curly brackets?
Yeah.
All right here?
Yeah.
Okay. I mean, you can easily look that up, and there's examples of it. Now, let's say I create a method, and one of my inputs is going to be direction. Will be that. So what the person, when they enter it in, all they would do is they can't add anything in unless it's going to be one of those. So so it makes it strict. So what we're going to do is we're going to create like an employee kind of, we're going to learn how to do classes and all that kind of stuff. We're going to use this concept. Don't worry if it's kind of foggy in your mind, because when we implement it, I'll point it out again. But I just kind of wanted to quickly show you right here, right now. So let's say we're going to have an employee. We're going to put a gender in there, male and female. So, and we'll create it as, let's say, an enumeration type called gender, male and female. So all they can enter in is either gender male, gender female. And I'll show you how to use it and access it. And later on, when you're doing, by the end of the semester, you're creating games, it's going to be very, very useful. Particularly, right, if you're going to have something with directions in the game, something pointing, something's moving, a state of a particular object on the screen. Maybe you could have somebody that's running, jumping, walking, right? They can all be enumeration types. Okay? So you'll see the power of this as we move along. Okay? Now, what we're going to do is I'm going to review what classes and methods are again, but I'm going to go quickly on these things. So when we look at a class, so you can think of a class as basically like a blueprint. Okay, so it's kind of like a blueprint for something that you're going to use. And inside it's going to have code inside it, obviously. And basically classes have methods, which are like actions or commands. We'll look at those. And we never looked at these last year, called properties. Okay, we've used them. And these are like characteristics or attributes. Okay. When we use a property, we always use the equal sign to assign a value, or we just reference it by its name to get access to what value it is. Like a text box. Text box class has a text property in it. We can assign the value by using the equal sign, or we can just get access to what's in the text box, like when we're reading in an input. Remember what you guys do all the time, right? It's a property. Whereas a method always uses these parentheses, right? And then you have inputs into these methods. And you could have 0 inputs or as many as you need. Okay, so we're going to be looking at how to implement these and a whole bunch of other features that are related to classes. So we're going to look at object-oriented programming, and we're going to look at some of the principles that would make a language object-oriented, or an object-oriented language, right? So there's inheritance, there's polymorphism, there's encapsulation, and that abstraction. Okay, those are the 4 that we're going to look at. I reorganized the notes and everything. They're different, so please bear with me if there's mistakes, because I redid them all, and I read through it, but it's very simple. It's very easy for me to make a mistake on something. I had kind of these principles all out of order before, but now I've found a different approach to it, which I think will be a little bit more effective. So I hope I didn't make any mistakes, or very few, that I don't want you guys to get confused. Okay? So what we want to look at today is look at how do we just even create a class. I mean, there's a template for it, but we'll all show you from scratch. And then how we can add a method. Because that's the first thing that we should learn how to do. Okay? Now, a class is like a blueprint or code, but it's typically going to represent something. Now, I write the word something in there because it depends what it's going to represent something in your software or your program, however you want to look at it. But something could be anything. Let's say like I said, if I'm creating a game, there's so many somethings that are going to be in the game. If it's a game like, let's say we're going to try and create like a FIFA soccer game, you got players, so there's like real people in there, right? And then, so you're going to do that. You have a ball, you have a field, you have stadiums, right? If you're doing something like Call of Duty, what are the kinds of things that you would have in a game like that. Like all the objects that would be in the game. It's like guns. It's different kinds of guns. And those different kinds of guns would be implemented in the properties. So you can have a class that's called a gun, and then there's a property called type. And then we would create an enumeration that would list every single type that's in there, and you could only have one of those types. Okay. So what else would you have in there? You got guns, grenades, explosive device, soldiers, right? Maybe there's different soldiers, different. You probably have a soldier class, and then you might have an enumeration that would specify what type of soldier. Captain, corporal, just the grunt, whatever they call it, private, or what's right? So you have bullets, you have all kinds of, you have tanks, you have aircrafts, you have all kinds of stuff that are incorporated within that. And you want to represent those as a class. Yeah. Okay? So when you create a game of that kind of magnitude, right, you're going to have a class that's going to represent every one of those objects. So if you've got like 100 of those, 100 different types of objects that you got to model in your software, you're going to have 100 different classes. But the beauty of it is, when I create, let's say, a soldier class, that soldier and everything about that soldier is just in that one file. And it's in that one class. And all the methods in that class only relate to a what? Soldier. The problem, right? I could go to a bullet class, and all the code that's in that bullet class is only for that particular bullet, nothing else. Right? So bullet, I'm going to have two classes that have the same method inside it. Maybe there's a method called run in two different classes. I don't know. You have a soldier and maybe you have an animal in the game. Sometimes they have dogs in the game. So let's say you have like an animal and it's a dog that's in the game and uses whatever they'll attack. So the dog's running. But you could also, and that would be a method that you would code for. But that would be inside that animal class. And then that relates only to an animal. So when you say animal run, only the animal's going to run. And it'll run in its behavior based on how you code it. Whereas the run that's placed inside the actual soldier class would just be for a soldier. And the soldiers are usually human, unless they're robotic or zombies. They got all that crazy stuff in those games. Okay, so if I'll record this. And so the beauty is that I got like all my code is separated and organized into the actual file or class that is related to that particular thing or object or whatever that something is that I have to code for, right? It could be anything. Later on, we're going to do a card game. So you got there's lots of different objects in a card game. There's a hand object. There's a card, right? The hand is just a number of cards. So that's kind of like an array of cards. So it's like all these, right? So and then every card's going to have a suit and it has properties. So we're going to look at this kind of stuff. Okay. So when we're coding in this way, it really breaks up your program and it organizes it into very nice parts so that things don't crisscross. So if I see a run command somewhere, I just got to look at what class it's from, and I know that run command is for that animal or for that. In the olden days, before object-oriented programming, I'd have a run procedure or method, and it would be in one file along with, I'd have the run and the animal in one, and run for the soldier in the same file, and try to figure out which one's for which. Right? You probably call it run soldier, run. It just used to become what we call spaghetti code. Just code that mixed and intertwined. You know, spaghetti just mixes all together, and you pull it up, and it's all crisscrossing, it's all mangled. Good luck trying to find one piece of spaghetti separate from the other. You can't. It's all tangled, right? So they came up with object-oriented programming as a technique to What's that? Yeah, to make that spaghetti so it doesn't crisscross it. You right? Streamline everything. You put everything in its own special little container. So it's very, very powerful. Most software is designed and programmed this way. Okay? So it's very important that we understand this. I mean, I have to walk over to click this thing because the mouse. So to create a class, all you have to do, well, I mean, you could go file, add new class. It'll add the template. But what it would typically add is, it might put public in or might not, public class, and then you put the name over here. So, and then I'll just write name. Whatever the name of the class is. And then you would add that in. So this is standard, and then you add this in. Okay? And then you have bracket, bracket. Save your file. Typically, you should save your class name. Whatever you name it, that should be your file name also, so you'll know where it is. You don't have to. Languages like Java, it's a requirement that the class name and the actual file name match. But in C#, it doesn't matter. I could call this class name and call it food. Did you guys like that on the test? The word food?
No, that was a way.
That's like something that's in like a lot of books. They'll use that. Foo is like a Microsoft thing. They love to use that when they're giving out examples.
When I learned JavaScript, they use foo like for every example. It's like, wait, why does it return? Did I do something wrong with this example?
Foo, it's just like a stat. So I use stuff that I know that you might come across later on. So you'll be like, oh, okay, it's just a stupid name. When you don't have anything important, any important name to give it, like an example, you use something like foo. So public class name, this, done. That's it. Save it. Okay? Inside this class, I can have kind of 3 parts to it. Okay? This is all going to be kind of newish, right? So you're going to have private members or variables. Okay? You're going to have methods. And you're going to have properties. Okay? Different languages implement properties a little bit different. Okay? Not all of them implement them the same. When I talk about a private member, it's just a variable that I would create inside here, and then I could use it in any method. Remember how we did that? Like when we used arrays, I created inside that form class, and you can use it anywhere. So you can think of that as a member of the actual class. It's just a variable that's part of that class. If you make it public, I can access it from another class. If I don't, you can't. We're going to look at how we can hide things in here and everything. So we'll slowly get there. Okay? Now, what we want to focus on today is just how do we do this? Okay, this method. So you inside a class. Now, if you have a form, you can easily create your own method. Put it in there. Okay? Or you could create a separate class and put it there and then access it and use it in your form. So to do a method in a class, I'll give you the. So when we do a method, this is how you do a method. Okay? Now you're going to put public, private. Okay, there's a couple other ones. First, you have to state what its accessibility is, whether it's public or private, and there's a few other ones too. But okay, so you typically put public in there. Okay, if you don't put anything at all, I believe it defaults to private. Okay, then the next thing you're going to do is you're going to have its return value of the method. Okay, if there is no return value, you put void in here. That means the method won't return a value. It'll do something, but it won't return anything back to you. Okay, if not, you put a data type over here. So it could be int, double, it can even be an array. It can even be another class object. It could be anything. It could be an enum, it could be whatever it is. Everything's open to it. There's no limits really. You can't make it return back another method though. Okay. So data return type goes over here, okay? And then I believe all we have to do is put its name, okay, method name, and then you put your bracketing over here, and then inside here you'll have your inputs. Now these are going to be values that are coming into that you want to have access to inside your method. So you might have a piece of code somewhere where you have, like, you read in your input values, let's say from, the user reads them in from the Windows form, right? You want to be able to pass those into maybe this particular method to do something with them, like a calculation or something, okay? Every input parameter has a data type and a name. And if you have more than one, you separate by a comma. And you put its data type and then its variable name, and then data type and its variable name. Okay? This is an important note. If this data type is one of the primitive data types, it creates a copy in memory. So if I have int, or let's say string last name, string first name, those are my two inputs for some class, some method for class. No, maybe I should use, maybe we'll do int width, int height. We're entering the width and the height. Because they're primitive data types, those variable names called width and height create a copy of what's passed into them. So I might read in the numbers 3 and the number 6 for width and height. I'll pass those into here and into here. They make a copy of them, and those copies are used inside this particular method. Okay? So I could change them. I could have a different value for them. It will never affect the original value that was passed in. So the 3 and the 6, those values still exist in the class that called this method, right? Or the form that called it, let's say. Likely that's where it'll come from. And I can do whatever I want with those variables. So basically when I do that over here, you're creating variables. Everything that gets put over here, it's like you're creating the variable, but you're also assigning kind of like an initial value to it, if you want to look at it that way. Because when you call this method, you have to put in what the values are for those. And they have to match the data type and everything. Okay? And then what you do is you put your curly bracket here, your curly bracket there, and then all your method code gets run inside here. Now, if you have a return type other than void, right? Your data return type, if that's anything other than void, you have to call return, and then you put a data type over here that has to match this, semicolon. So once your code runs, and then it hits return, and then it's going to return the value. So let's say passing width and height, and then I'm calculating area. So this return would be the variable, most likely probably area, and then that's the answer. So the person that calls this particular method would read in the width, the height, calculate the area, use those variables, calculate the area, and then return. And then this way, the person that uses that method get the answer. If not, the answer it gets lost in memory, right? It won't be gone. You have to have the return value. Just like when you do math.round, you set something equal to it, right? Well, the math.round returns what the rounded answer is, and you have to assign it to it. Yeah. So we're just creating our own with the same kind of thing going on here. So let's say I wanted to do that. I wanted to create, let's say, calculate the area. Now, let me just, for some reason, the structure seems to be off in my head. Maybe I'm missing something. No, I got it right. I don't know why I thought I was missing something. I don't know why. So let's say I want to do width and height. I'll do something like this, or the area. So I would do, let's say, public Okay, and then I'll say double, and then area, and then I would say double width, and then double height. There's my chicken scratch, bracket, bracket. I can now use these inside here as if they're variables that I would create in line. But the bonus is that when I use them, these already have values in them, right? Because they get passed in when it gets called. That's the only difference. If I had created them inside here, don't recreate them because then you'll override them. It'll be default to 0, right? So now I can use them as if there were variables I created inside here. So then I can create double area equals width, whatever, times the height. And then I could return area, and then that's it. So when someone calls this, right, I have to have a variable on the left-hand side equal to it, because whatever gets stored in here is going to get sent there, and it will get stored. We'll look at it a little bit more when we do it. Do an example.
You don't have to put those brackets beside area.
Right here? Really, I shouldn't make this name the same. So I might make this lowercase. I think it'll work if I do it, but it's kind of, you gotta be careful. So sometimes you might see someone put a little M in front, or do a little something in front, or just make it a different case like lower. But I think if we do double area, it'll know that if I do it up here with the double area, capital A, it'll use that it'll work. I'm pretty sure. We'll test it out. But it doesn't have to match. This doesn't have to match that. Just don't think it does. Just that the naming works that way. This is not a method. This is a variable. That's why there's no bracketing after it. Okay. So what we want to do is we're going to start building an employee class, and we're going to start doing some things in there. But maybe we should just do a quick little example of this, because some people in the second semester we spent more time. People in the first semester we really didn't. So let me see what I got in my notes, and just want to look ahead a little bit. All right, why don't we just, we'll create a new project, okay? Let's do a new project. Let's make it a Windows form, because we can add as many classes as we want to it. Why don't we call this Employee Manager? So this Employee Manager is going to manage all of our employees that are within our particular organization. Okay, then go ahead and save that, and we can make it a Windows app. I just got to change my location here. Just set up your form real quick. Give it its title, its start position, right? Okay. What we want to do is we're going to add a class that's called employee. Okay, so for every, right, we'll create a class called employee. So we're going to right click the employee manager and we're going to add a class, and we're going to call that class employee.cs, and we'll add that. And notice that it creates class employee for us, like we don't have to worry about it. We should put public in front of it because we're going to need to access it from our form. So make sure it has the word public in front of class. If we take a look at the using text, link queue, and collections, you could delete those. We're not going to use those for right now. Okay, it's just my employee class. We might have to use other using. We'll see later on what comes up. I don't think we need anything other than system for now. Let's say we're going to create. There's a lot of things that we want to do here, but to try to illustrate what we've done so far is maybe we're going to create a method called pay, and based on our hours that we work and our pay rate, we use those as inputs. We can go ahead and calculate what someone's pay would be. Make sense? So let's create a method that does it. Because I don't want to use those same examples last year like we did with the circle and the rectangle and all that. Okay? So in order to properly do this, we'll create a method. Okay? We want to make the method public so that we can access it from another class. Because our programs are always, if we look at our files, all our files are just classes, right? So if it's private, you can't access it. And sometimes we want to do that, but we'll talk about that at another date. So we're going to go in here, and we're going to create a method that, what I like to do actually is this, create a little section called methods. Sometimes I even do this. You know, you could do something like that. Just so it kind of highlights every section. You kind of put it like a line there, because we'll have a section for our properties and a section for our global variables, or well, we'll call them private variables. What's that? This right here? Yeah, if you do this, I never showed it to you guys, but if you do slash with a star after, I could hit, and then like that. I think you could put number of comments on a number of lines. Works like that. Doesn't matter, you could put 2 of them there. I put the stars in there just because it just looks good. But it does work. But if I took out this one and just did it like that, I'm not sure it would work. I guess, no, see, I'd have to close it at the end like that. This way you can put it on multiple lines. But yeah, just do it like this. It's better if you do it like that. Sorry. Just out of habit. I don't show you everything, you know. So let's create a method. So this method, we're going to say public. And it's going to return the person's pay. So if it's going to return a pay, double or int, what should we use? Double. Double. And then we give it a name. We'll call it pay. and then we'll put our brackets in, and we gotta specify what the input parameters or input arguments would be. Okay, so I'm going to say that we're going to base it on hours and pay rate. Okay, so we'll do a double for hours, and we'll create a double for pay rate, just like that. It'll give you an error under the pay because it's telling you haven't used the return yet. So it's trying to remind you. You know that the return keyword? So don't worry about it. When you put it in, we'll put it in. It'll get rid of it. Okay? So what we want to do is we want to calculate the pay. So if I put this in, it should be fine. Equals, so it'll be hours multiplied by the pay rate, right? And then we return pay like that, and then that's it. It's probably good in the first line. What I usually do is calculate the pay based on hours and pay rate for an employee. It's nice to do a comment on the very first line of your method to say what the purpose of that method is. You see what I did there? I put the purpose there. And then I don't really have to do any comments anywhere else because it's pretty self-evident what's there. Like anybody looking at that code will know it's just a simple calculation between those two variables. Okay? These variables, hours and pay rate, that are input in, will make a copy of the original values. Okay? So even if I were to change them inside here, like I said, hours equals hours times 2, doubled their pay or whatever, doubled their hours, right? It would, like if it's overtime pay, right? So a person with overtime pay will get time and a half. So they might have double, they will have overtime hours and then the pay rate. Pay rate's the same, but when you go inside here, the overtime hours are going to get 1.5. If it's a holiday, sometimes they're double. So we could do a method with that. I'll get you to do that. Okay? And what happens there is, even though that hours gets changed inside our method, it doesn't change the value that gets passed into it. That stays. Because you might need that, which is good. Okay? So whatever happens inside this method stays inside the method. There you go. You can think of it like that. You know, whatever. When you go to Vegas, stays in Vegas, right? Whatever goes on in this method stays in the method. Only if it's a primitive data type. If it's an array, forget it. Or an object, Everyone's going to find out. It's reflected everywhere.
How was the party on Friday? Did you go?
Yeah. He was all worried. I hope these students aren't coming. I'm like,
I think you told me. I'm like, no, it wasn't Mr. Arnott. He's like, was it Miss Goma? I'm like, no, he's like, was it Miss Kiddo? I'm like, no.
it's like he was all like worried. I hope these students don't come. This is not good.
Miss Girl looked up a
Did you ask him how the party was?
Oh, shit.
Now, I can use this method anywhere inside this class. All I have to do is just call it by name, pay, and I could use it. Okay? If I want to use it from another class, I can't just call pay because it'll be like pay from what? Right? So what you have to do is you have to create a variable that is an employee, just like we do when we create console or math. Well, we don't use a new keyword with those, but some of them we have to. But we'll have to create an employee, right? Object, and then we'll have use the new keyword, And then we'll have access to this actual, all the methods and properties and whatever else is there. Okay, so we're done with this right now. And what we're going to do is we're going to go back to our form. And we're just going to put a button on there. Forget about inputs for right now. We're just going to say OK. And then we're going to call it BTN OK. And then we'll double click it so that we can add code. I can't call, if I wanted to call pay like this, I can't. It doesn't show up. Notice in IntelliSense, it doesn't show up. It's not accessible here. If I just call employee dot, notice that it doesn't show up. I can't call it like that. I actually have to create a variable that is an employee. Just like I create a variable that would be a double, a variable that would be an array, a variable that would be, right? So in order to do that, you just type in the data type, which is employee. We'll give it a name, Ivan, equals. Now, that's not good enough because you have to initialize it. Like if I just do this, it's, remember, just like the array, it's pointing to null. It hasn't created anything in memory related to that particular object yet. So you have to use the new keyword, equals new employee, and we'll just do that. Later on, I'll show you how the new gets used in a more complex when we add a constructor to our class. Okay. So now I have an employee. I call him Ivan. Now the variable Ivan, that variable's good. It can access all the public members and all the public properties. We only have one in there. It's called pay. So all we have to do is, I'm going to create double, and I'm going to call pay, and it's going to equal Ivan dot pay. Whoa, I spelled his name wrong. Dot pay, there it is. And then hours, I don't know, let's say he's a student, so you worked 15.5 hours. And what's minimum wage?
It's $9,000.
No, $11.50. You get a little bit better. There you go. Okay? And then we'll just do a message box dot show, and then pay equals plus pay. So when this method runs, so when I go inside here, so whatever gets calculated in this pay variable inside here gets returned. And then that's what gets sent back, and then that comes all the way back and goes into pay and gets stored in there. Or whatever I don't have to make this, I don't have to call that pay. I can call it anything I want. I can call it foo, man. Whatever. Okay. Now I didn't create two variables, but we could. So I could create a double called hours, and then it equals 15.5, and then I could create double called rate, and then that's 1150, and then I could use those in here. Okay, these variables outside here that get passed in, they will not change, right? They will come into pay. Okay, they get copies of the values, and then they get used inside here. So even, I know I didn't change them in here, but even if I were to change them in here, these values out here, because they're primitive data types, hour and rate, don't get affected. And then I can use them again later on. Maybe I do multiple calculations with it. I know that they're not going to change. So now if I run this, actually, you know what I'm going to do? Let's step through. So let's see how it works before the bell rings. I click this, it stops here. I'm going to press the button step into. So it's going to go in. Notice how it's 15.5 and 11.5. That's good. Step into the code. It's going to go in here. It calculates my pay. Okay? And then that gets returned back. Notice that that's still 0.
Yay! No, we didn't get wrong. The It wasn't me. It wasn't me. It wasn't me. I swear it wasn't me.
What? The whole school's out.
Wait, can we go?
Alright, so power just went out.
Love your stories.
Alright, just relax. Hold on. It's like 2:40. Shh.
Roy!